Hello and welcome everybody to today's lecture about overcurrent protection and especially about current versus time grading for distribution transformers. First, let's look into the principle. A transformer can be thought of as a lumped impedance between the source and the consumer, and we can have faults upstream of the transformers which are very high short circuit level. We can have faults downstream which have a lower short circuit level, and also faults at the end of a long line. These faults can be also considered. First, let's look into the high set element of the transformer protection. So we have different fault current levels. The highest one, of course, is the fault current level upstream of the transformer. The lower one is downstream at the busbar, for example, and the lowest one is the fault circuit level at the end of the longest feeder. Also, for the sake of completeness, we should put in the nominal currents of the transformer at that one of the feeder. And now let's see how to set the high set element of the transformer protection. As we can see here, we have a current gap between the fault current level at the high voltage side and that one on the low voltage side. So either the current is high, then the fault must be on the high voltage side, or it is low, then it must be on the low voltage side, and that can be used for discrimination. And now we concentrate on the green circle, which is a zone where there is no fault current. And this zone can be used for discriminating between high voltage side or low voltage side short circuit. So we can set the discriminating value, that is the pickup value of the high set element here, a little bit up or down. But in any case, it should not infringe with the safety margins. One safety margin, that is the one towards the high set side, is that it must always pick up for a current. So the pickup value must be below that. On the other hand, it must not infringe with any fault on the low voltage side, so it must be above the highest low voltage side current. So the time is T1 because we must not wait for anything, and the tripping can be carried out immediately once such a fault has been detected upstream of the transformer. The next element is the feeder protection. This is in the sense of overcurrent time grading. We must work up our way from the end towards the source. So here we have two limits. One is the nominal current of the feeder, the other one is the worst case of the lowest short circuit current, that is a short circuit at the far end of such a longest feeder. So we can take a pickup value here or there, but in any case, again, we must not infringe with the safety margins, which are concerning the high set side. It must always pick up for the worst case. It must be below that short circuit current. On the other hand, it must not infringe with the normal operation of the feeder, so it must be above the nominal current of that feeder. So the tripping time may be chosen as T2. So this is the setting of the feeder protection, which is downstream. And now we can use also an additional function of the upstream overcurrent protection in the sense of a backup protection. So it should pick up if the feeder protection does not trip that fault. So the tripping time is quite clear. It must be above the tripping time of the feeder. The new tripping time is called T3. But how about the pickup current? The pickup current should always pick up for the worst backup case. That is the short circuit at the far end of the longest feeder. So it must pick up below that value. On the other hand, it should be above the maximum nominal current of the transformer in order not to impede normal operation. And if we have found a value, for that, then this is the complete picture. So the tripping time is T3, and this is the full picture of a high set element, a low set element on the high voltage side of the transformer, and a feeder protection which operates after T2. Thank you very much.